Today we'll be looking at the specimen for this year exam. And before we go into that, I will want to address some questions I've been receiving from my Facebook page in regards to how to really deal with ions, the salt analysis. That's what I want to do today. I want to look at the salt analysis. And this problem has to deal with, because I have gone through, from experience, I've noticed that each time I try to give students some questions in regards to salt analysis, they will be able to write out the observation, but the inference seems to be the biggest challenge for most students. And in my page, that study guide forum page, we find out that most often students used to ask us the same question: how can we know? How can we know what should be in the inference? Actually, before I go into these details, like I said, before I go into the main meat of the matter today, I want to guide you in a way to understand how to really know what will be in the inference. Number one thing you should know, that what your examiner is asking you to do is already what they call predetermined test. It's a predetermined test. That is what do I mean by this? A predetermined test is a test that have been confirmed. It had been confirmed so many years ago. That is just like we know that if you jump up, you must come down. If you jump from a skyscraper now, definitely you will come down. Just like what goes up will come down due to force of gravity. So whatever they are asking you to do, whatever test they are asking you to do, is already predetermined in regards to whatever ion they want you to identify. That's one thing you should have in mind. So what does it mean? What it simply means is that since a test is predetermined, you should be able to know. The first thing you should know is that that particular test that can confirm each of the ions is very important. Very, very important. That particular test that confirms each of the ions is very, very important. It's important that you note that very test. Just like, for example, chloride ion. One of the tests for chloride ion, one of the predetermined tests for chloride ion is a test with silver nitrate in any solution that contains chloride ion. One thing you will notice in that is that you have a white precipitate. That white precipitate confirms that the presence of what? Two cations, two anions. That anion could be, because silver, like we said, like I told you, it's a predetermined test. Silver has two white precipitates. That is that of triisocarbonates. Silver triisocarbonates. You have alright. And we have another one. What am I writing? Silver chloride. These are the two compounds of silver that will give you white precipitate. For now, how do you differentiate the two? How do you differentiate that this is actually chloride and this is other one is not? It's chloride and it's not silver triisocarbonate 4. That is not that. So how do you differentiate? Now for this, in addition of acid, perhaps most often we use silver nitrate. We use a triisonitrate 5 acid. When you add triisonitrate 5 acid to each of these compounds, that will be effervescent. This one will give you carbon 4, which turns lime water milky. Why this other one will not dissolve? Because silver chloride is always insoluble. And perhaps if you really want to go a bit further, before testing with this, you can expose the precipitate in solution, the precipitate in that solution, to sunlight. Once it's exposed to sunlight, you notice that it will turn gray. That's because of it will be oxidized. It's normally affected by light. Do you understand? Once silver chloride is exposed to light, it turns gray due to the exposure to sunlight. That's one of the things that can help you to really stress where the compound is coming from, whether we have a chloride ion there. But now, in addition of this, you find out that the the pressure will remain. Now, what do you do next? You can also use ammonium, aqueous ammonium, to really go further. So this test I have just explained to you, it circles around what? Test for what? Chloride ion. This is one of the tests that you need to pay attention to. Now, everything I want to show you now before I go into the specimen of this year exam is just before I go into that, I want to show you all the possible ways to, so that you'll be able to infer, so that you'll be able to write something, to know what to put in the inference of each of the questions given to you, each of the tests you are carrying out. Now, based on this now, normally in the exam we are writing, we normally test for calcium ion. Also, we have zinc ion. We have aluminum ion. That's for cations. That's what I really want to deal with today. And then we have another one, ion 2 ion. We have ion 3 ion. We have a copper ion. And then in some cases we also test for ammonium ion. So now, one thing I want to point out clear here, most often when you have some of these compounds containing any of the compounds containing this ion, most often they ask you to dissolve in water. Now, when you dissolve in water, there's something they want to find out. The examiner wants to find out something. What is that? The solubility of that. Now, there's something about this. When we look at this, so we're supposed to have sodium. Perhaps in some cases we can also add potassium ion, as the case may be. So they want to find out your ability of knowing the solubility of some certain ions, because there are some ions that always dissolve in water, that in every case they are soluble in water. So one of these ions that are soluble in water is potassium. Another one is sodium and ammonium ion. Now there are other ones which, well, I want to capitalize on this issue of the cations. Perhaps in other one we talk about the other anions or radicals that can also dissolve, just like this one is soluble in every case. Does not have any insoluble of this. Hydrogen triazocarbonate 4 does not have any insoluble compounds. All of them, in every case, they are all soluble. Just like the same thing with nitrate. Nitrate does not have any insoluble compound. That's another thing you should know. So now, based on the information I have given you so far, these ones, there's something about them. They give you soluble compound. These soluble compounds, most often they are colorless. So in other words, when you are testing, when you add a water to a compound you are testing, you notice that you have a soluble substance which is colorless. That means because you don't really know what might be inside there. That is why in most cases, in order to infer, you can even go there. You can go to your inference column and write what? Soluble salts or soluble ions. Perhaps you can also go as far as listing out these ones that you know that are always soluble in every case, because these other ones are known to be soluble and what? Colorless. But there are another thing you should also know. Then we have also in this we have another one that can give you color. Perhaps we take it one after the other. So when we talk about the soluble ones, just like sodium, potassium, and ammonium ions, they are soluble in every case. So we have calcium. For calcium, this calcium we have here, the calcium has some soluble ones. Some of the soluble ones, compound of calcium is calcium chloride, calcium nitrate. They are all soluble. The rest of them are what? Insoluble. Now we have another one we have here. We have zinc. The zinc we have here, we have some other one that are soluble. We have zinc nitrate. Like I told you earlier on, zinc nitrate has no insoluble compound. We have another one, zinc chloride is also soluble, and we have zinc tetraoxide 6 is also soluble, and also zinc triazo sulfate 4, they are all soluble. The other one, we have this aluminium. We have aluminium. Now, why am I doing this? It's just to help us to know how we can handle solubility tests. That is, that time you add water to it, one of the things you're doing there is just to test the solubility of the compound you're looking, or the salts you are trying to test. Now the next one we have here aluminium. We have aluminium. Aluminium chloride is soluble. We have also aluminium nitrate, also soluble. Aluminium tetraoxide 6. Tetraoxide 6 is also soluble. Now we'll come over to iron 2. Iron 2 chloride is soluble. Iron 2 chloride is soluble. Iron 2 tetraoxide 6 is also soluble. Iron 2 nitrate is also soluble. These are the much I can remember. Actually, there are other ones. We also have in iron 3 chloride, we have iron 3 ion. We have iron 3 chloride soluble, iron 2 tetraoxide 6 soluble, and then we have iron 3 nitrate also soluble. Now for the copper, we have copper chloride soluble, copper tetraoxide 6 soluble, and we have copper nitrate also soluble. Now for the zinc, which I've already stated before. Now for this one, everything about ammonium ion is what? Ammonium ion, ammonium compound, they are all what? Soluble, like I've already stated before. Now, then the next thing we are going to do now, we're going to be looking at based on colors. I will try to be a bit fast in this so that we can meet up. Based on colors, there are some of them in the solution, they have color. Colored ions is mainly as a result of what we call transition ions. Transition ions. Now you notice that the area that I just marked, we have the true transition ion, although zinc happens to fall into transition elements, but the ions is normally considered not to be true transition because the D block is filled up. Now these transition ions, there's something about them because each time they combine or form bond with the D block ion electrons, they tend to fall into the visible light region where they show up color, they display some colors. That is one thing about them. For this iron 2, iron 3, and copper 2 ions, all of them shows a kind of color whenever they are in compound. When they are compound dissolved in what? Water. So they always give you color. So what it simply means now, if you add a substance, if you add a salt into a solution and you have color, now you have a color. As your observation, you said colored solution. That means that thing, because that thing has color, what it simply means there is that your inference should contain something like transition ions, because transition ion is known to have color. Each time each of these ions, any of transition ion that has any of transition ion that combine with the D block, note when the D block electron is involved, they must also give you what? Ion. But look at zinc. Zinc does not really give us colored ion. But then being a transition ion or transition element, what happens there is that each time you hit it, it gives you color. The compound gives you color. For example, when you hit zinc oxide, you have yellow color. It will change to yellow. This is because the D block electrons are excited when it's heated, to displaying the color, yellowish color. Whenever it's cooled down again to give you white color. So that is another character trying to tell us that guy, I'm part of them. Oh, don't just play around me. Oh, I'm part of them. So now when we look at this now, what, like I said, this is one of the things you can put there. When you have what colored ion, you can expect in your inference, you can add transition ion, likely what present. That's one thing you should note there. So the other ones you look at, the other ones that are colorless, whenever you have a colorless ion and you don't really know what's supposed to be there, when it's soluble in water, and give you colorless ion, like I told you, is far more better to use. If you are not sure of what to use, you can use soluble ions. But then remember, because it's not colored, means that transition ion is absent. That I'm talking about inference, and because I noticed that most students they're always having problems in that inference. What should be in this inference? What should be in this inference? That's always the problem. They will observe everything, because I have carried out a series of practical with students, because I always want them to do that in themselves. When they are doing it, I find out that most often in the inference they are always having problems. So that's why I choose to do it this way, so that at the end of the other day, when I'll be analyzing the ions, you find out that whatever I'm inferring would be aligning with whatever like we said, predetermined, the predetermined experiment. You understand? The predetermined test that is meant for that very ion. So now the next one we look at here, like I already told you, have ion 2, ion 3, and copper 2 ion. Like I told you, they are all what we consider to be 2 ions. There's another thing I want us to look at here. Now there is salt. This ion in their salt, they measure reagent for these reactions, which I will just rest my case there, which is sodium hydroxide, and what? Aqueous ammonia. Sodium hydroxide and aqueous ammonia is one of the major reagents for this test. So these are the major things that we use in testing it. There are other ones. Perhaps in the next video, I will see if I will look at those ones, like something like potassium iodide. No, potassium iodide for anions, which I will talk about later. So just like for this, we have potassium hexanoferrate and all those materials. Potassium hexanoferrate 2 and 3, which we normally use in test for ion 2, ion 3. That is another thing. So we can also look at those ones and then find out how we can match with what we are doing. Just like there's a compound, that is an ion that is not here, which is lead. The 2 ion. For the 2 ion in other tests, besides using sodium hydroxide and aqueous ammonia in testing, the 2 ion can also be tested with potassium iodide or potassium dichromate. This is where you have a yellow precipitate, which confirms the presence of lead. But what I want to do here is just to help you understand what kind of reaction we expect, already predetermined test using sodium hydroxide and aqueous ammonia. So I want to encourage you to just pay attention and watch as I explain all this thing. And if you are joining us for the first time, I want to encourage you to click the subscription button. If you like what we are doing, you can also click like. If you have a question to ask us, just leave it in the comment section. We will always attend to you. So let's continue with what we are doing. So I said I want to rest my case on these 2 common reagents for all these ions. For these ions we have here, in their test, we have some of them that will give you precipitate. Some of them will give you precipitate. Some of them will give you colored precipitate. Some will give you white precipitate. So we're going to be breaking it down. We are going to be breaking it down one after the other, so that we will know those ones that give us colored precipitate, white precipitate, and gelatinous precipitate. Now some will give you white gelatinous precipitate, while some will give you what colored gelatinous precipitate. It could be blue, it could be red, it could be brownish, it could be let's say blue, green. Is it green? Yes, something like that. Should be something like that. All of them. We're going to be looking at them so that we'll familiarize ourselves with it. Because once you know all these predetermined tests and the observation you see, when you each time you see this observation, you will know exactly what will be there. You should not be shaking. You should have the confidence that whenever you have this, perhaps an expression where you're testing for iron 2, you add sodium hydroxide, you have white gelatinous, you have a green gelatinous precipitate. Exactly, you know that what's supposed to be there is no other thing than what? Iron 2. A green gelatinous precipitate that insoluble in excess sodium hydroxide, confirm the presence of what? Iron 2. So once you're able to see those observations, you'll be able to know where and where to add your this inference, what is expected from you. This thing I just stated now is one of the predetermined tests for what? Iron 2. So let's go. Now we talk about we look at the ion with sodium hydroxide. The actual ion with action with sodium hydroxide. I said that we have some of them. We have some of them that will give us colors. We have some that will give us let's say gelatinous precipitate, and we also have the one that will give us under the gelatinous precipitate. We can also have the one that will give us colored, and we have another one that will give us white with sodium hydroxide. Sodium hydroxide, note very well. And also in this precipitate we have another one that will give us just white precipitate. We have the one that will give us just white precipitate. Now for the gelatinous precipitate, the one that will give us colored precipitate used to be what? Iron 2. That will give us the color precipitate we have here is normally greenish, dirty green precipitates. And then another one we have is iron 3, which will give us a brown precipitate. Now the next one we have that will give us another precipitate with sodium colored gelatinous precipitate. Colored gelatinous precipitate is what? Copper 2 ion, which will normally give us what? Pale blue precipitate with sodium hydroxide. Pale blue precipitate. Now this gelatinous precipitate, under the white gelatinous precipitate, remember we're talking about gelatinous precipitate now. Under the white gelatinous precipitate, we have zinc ion with sodium hydroxide. We also have aluminum ion, which will give us white gelatinous precipitate. This gelatinous precipitate will always, two of them will give us, so it's soluble in excess. Now, what does it mean? When you are doing this test, you find out that you have white gelatinous precipitate with sodium hydroxide, and then you add in excess, you have what? Soluble substance, which means if it's soluble, what it means there, in your inference, remember to indicate these two. That's just how to do it. It's very, very simple. Because two of them will give you what? White gelatinous precipitate, and this white gelatinous precipitate is soluble in excess. So once you get white gelatinous precipitate, which is soluble in excess, which means you are likely to have this or that. But there's another way of separating them. There's another method of separating these two. If you want to separate them, we'll get to that. But then let me just give you a hint. One of the ways of separating them, which means when you test this with that, the likely test, another test that's likely to come up there will be what? Testing it with aqueous ammonia. In aqueous ammonia, this one is insoluble, while this one is soluble. That differentiates it. Well, another thing that will happen there is that the insolubility of this in aqueous ammonia That we will talk about that later. Let's continue with what we're doing. Let us not be too fast. So this is one of the ways of knowing what to put in the infer. See how easy it is. Because once you have that something like that, you see that why gelatinous present, two of them, why gelatinous, that is why two of them should appear in your what inference. That means likely present. You see that this is present, or you see that zinc is present, or aluminum ion is what present. Now we are done with the gelatinous precipitate. As we can see, another one we have here, we have the one that will give us white precipitate. The white precipitate that we have here, we have the one that is a kind of powder, which is calcium ion, and another one that will give us this copper, lead, or normally it's somehow called the, that we have a lead ion. The two ion will be there. So looking at this now, when we have a powdered precipitate, that means we are likely to look at these two. Because this is white, all of them, two of them are white precipitates. When you have something like that with sodium hydroxide, that means you are likely to be expecting something of this nature. So this precipitate now we have, meaning that in your inference, you are likely to have calcium ion and lead ion. Now there is another way of another predetermined test to separate them. One of these tests is maybe you can add dilute hydrochloric acid. That will make this one to be what? Insoluble, because lead chloride is insoluble. Once you add it there, you find out that lead white precipitate will appear, telling you that lead is there, and then it means that calcium is not likely to be there. So for this one now, to actually test for this, I think I should be doing that now. To actually do test for calcium ion means that you use sodium triazoxide carbonate. In addition of sodium triazoxide carbonate, what we have is white precipitate of what? Calcium triazoxide carbonate. Then sodium ion will combine with whatever compound, radical anion that is part of this radical or anion that is part of this calcium. You understand? That is kind of double decomposition reaction, if you can still remember that. So now we are done with this. Which other one do you have here? We don't zinc and all this. This is what we have in this case. So all these precipitate here, ion 2 ion, which is dirty green, is insoluble in excess sodium hydroxide. Ion 3 precipitate, which is brownish color, gelatinous precipitate, is also insoluble in excess. And also copper ion is also insoluble in excess. Note this very well. The pale blue gelatinous precipitate is also insoluble in excess. The next one we'll be looking at now will be test with aqueous ammonia. So when we're testing with aqueous ammonia, we also have two types, gelatinous precipitates, and we also have white what am I writing? White precipitate. We also have white precipitates. And in this, another thing, one unique thing about this is that we have one wonderful effect here, which will give us no visible reaction. No visible what? Reaction. What am I doing there? No visible reaction. So in this case, in aqueous ammonia, it's a bit different. So in aqueous ammonia, we also have gelatinous precipitate. This gelatinous precipitate we also have colored and white gelatinous precipitates. Colored and what? White. note very well this. Please, I want you to go through this. Pay attention as we are doing this. It will help you so much. Now, after this, you'll find out that those things that used to be scary as an inference, if inferring in your analysis will be a thing of the past. After following this thing very well, if for any reason you can also come back again and go through it, definitely go through it, and then you will be able to get this information, get it into your system very well. Now we talk about the colored ones. The colored ones we have here with aqueous ammonia is also we have with iron 2. Iron 2 is still what? Dirty green. Dirty green precipitate. We have another one, iron 3, which is also brownish precipitate, and all of them are insoluble in essence. We also have another one, which is copper, which will give you pale blue precipitate. In this time, pale blue precipitate, this time it will be what? Soluble, to give you what? Deep blue solution. To give you a soluble deep blue what? Solution. That's what we have here. So this thing I'm telling you now is one of the things that you see in the inference. So we have deep blue solution whenever. Now the difference here is that with sodium hydroxide, I found out that these other ones, all of them are insoluble in essence. But this case with aqueous ammonia, this is soluble because it forms a complex ion with ammonium compound to give us a deep soluble deep blue solution. Now, in the white precipitates, under the white precipitate, we have the gelatinous precipitate we have here. We have aluminium ion, and then we also have zinc ion. So in this case, this zinc precipitate here is soluble in SS, and this other one is insoluble in SS. Now when we come to this other one, we have lead ion, white precipitate here, lead ion, which is also insoluble in SS. Which is also insoluble in SS. Now, in this case, no visible reaction is a case of what? Calcium ion. In the case of calcium ion, we have what we call no visible reaction. There will be no effects with what? Aqueous ammonia. And then, one thing I want you to note here is that this is one of the things, some of the things you should note whenever you are working with what? Sort analysis, so that you'll be able to know how to infer in your analysis. If you're able to note all these things very well, we find out that sort analysis or qualitative analysis is one of the easiest parts in chemistry. In fact, it's one of the, because everywhere you take it to, it will always give you that, because this is a predetermined test for all these things. So I want to encourage you, make sure you follow this effectively. Go back to it again, repeat it, watch it very well, so that you'll be able to grab this thing. It will get into your memory very easily. Thank you so much for being part of this class. In our next video, we'll be talking about the anions. The anions that are, some of the ions, how to identify them, like chlorides, hydrocarbonates, ions, sulfate ions. We'll be looking at this thing. Thank you for being part of this. And if you are joining us for the first time, we want to encourage you to subscribe and then like. Any question you have, please drop it there. We are always waiting here. We are all here for you. Thank you so much.